welcome to class of physics. In previous video we studied about gradient of a scalar functions. From that we know the gradient of a scalar function results a vector function. In this present section we are going to study about divergence of vector field and curl of vector field. From the definition of del, we can construct the divergence of a vector field. The del operator is given by x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. And your vector functions phi equal to phi of x, x cap plus phi of y, y cap, vz, z cap. Then the divergence of a vector field can be written as del dot phi. This del dot v called as divergence. Then first write the del function. This is del dot product and a vector field phi. Now here we have to operate these two vectors. Then first we have to partially differentiate with respect to x the given vector field. But this is also a vector field. Here a unit vector x, okay, and here also unit vector x. For that this can be written as phi of x and x cap, that unit vector dot product is there. For that it is 1. For remaining multiplications it is 0, that is x dot y, x dot z, that is equal to 0. For that the first term of this divergence will becomes dou px by dou x and x dot x is 1. Similarly the second term we have to multiply these two, the dot product. Then here the unit vector is y cap. For that the term left is here the multiple of unit vector y cap. The remaining will becomes vanishes 0. So that the second term becomes dou py by dou y. Similarly the term dou pz by z. Observe here there is no any vector notations like unit vectors. For that you can say by these equations the divergence of a vector is a scalar. The gradient of a scalar function is vector, but here the divergence of a vector field is a scalar because it is operate under dot product. By using this method we can find the divergence of any vector field. So what is the significance of this divergence of vector field? Physical significance. The word divergence itself indicates spreading out from a point. The divergence of a function that is represented by del dot p is measures how much of vector is spread or diverges from a point. Sorry, here the spelling mistake. It is how much. For example, in the following diagram a vector function has a large positive divergence. Here there is a vector function, there is a origin. From this the vector field is going. This we call it as diverges from a point and it has a large divergence. Suppose the vector fields are heading towards a point, this kind we call it as negative divergence. You can observe in electric field from a positive and negative charges, so that will represent the divergence of electric field from the positive and negative charges. So like that we can find the divergence of a vector field, how much it diverges from a point or towards a point. If the arrows pointed in, it would be large negative divergence. And you can say one more example. So this is also divergence going from a certain point. Now how to find the divergence of vector fields? Now observe an example as a problem. Calculate divergence of following vector functions. Here three vector functions are given. We have to find the divergence of these three vector functions. So first one, vector field VA is given, that is r bar. This is the position vector. R bar indicates the position vector. It's x cap plus y cap plus z cap. To find divergence, or it may be a gradient, first we have to write the del operator. Del operator is what? X cap dou by dou x plus y cap dou by dou z plus z cap dou, this is y dou z. This is del operator. We have to find divergence. Divergence means this dot product of a vector. For that we have to take dot product x cap plus y cap plus z cap. The next step, we have to differentiate partially under dot product. Here three terms, here also three terms. First one, dou x by x dot vector field. Here this is having unit vector x cap, and here unit vector x cap, y cap, z cap. When it is under dot product, these two terms are vanishes because x dot y x dot z is 0. So that the first term becomes x cap dou by dou x into x cap. Similarly, the second term, here the second term is multiple of this one only. The two remaining becomes 0. For that, y cap dou by dou y of y cap plus third term is also similar, dou by dou z z. The next step, here unit vector x cap into x cap. Unit vector is a constant term. For that we can bring this outside the differential term, that it is x dot x. X dot x is 1, no need to write down. The remaining is dou by dou x of x. Similarly for the second term, y dot y is 1. For that, dou by dou y of y plus dou z by dou z. Dou x by dou x is 1 plus dou y by dou y is 1, dou z by dou z is 1. For that it is 3. The divergence of the vector field VA is 3. Now take the second one. The second one is this one. Vector field VB is equal to z cap. Now we have to find the divergence of this vector field. For that, del dot VB. Del is what? Del operator. X cap dou by dou x plus y cap dou by dou z plus z cap dou by dou z, and the vector dot z cap. We have to operate this one with vector. Then here there is no x terms. For that, this term is vanishes 0, and also here there is no y terms, so this is also 0. The only term is z terms, unit vector z cap. For that, z cap dou by dou z and z cap. Here z cap means it is 1 z cap. For that, z cap is a unit vector, it is a constant. For that, bring it outside the differential term. Then z dot z is 1, dou by dou z, the remaining is 1. Here 1 is a constant term. For that, this is 0. The divergence of the unit vector z cap is 0. And the third one, z cap. Do it yourself. Simply the same steps followed in 2. Here the 2 is, sorry, z is extra, and you write z here, then here becomes constant term becomes z, so dou z by z is 1. This is the third one. Like that we can find the divergence of any vector field. And the next one is curl of vector field. From the definition of del, we can construct a curl of a vector function or vector field. So again, the del operator is given, and the vector field v is vx cap, vy cap, vz z cap. This is a vector field. Generally, we are considering a vector like this. Then the curl of v, that is represented by del cross v, the cross product of del operator and the vector. So that is called as curl of a vector. Then del cross v is, this is the del operator and this is the vector field v. It is under cross product. Del cross v is a cross product, can be written in determinant form. For that, the determinant form is given here. Here we have to draw determinant lines. Now it is determinant. Del cross v, in first row the unit vectors x cap, y cap, z cap. In second row the differential terms from the del operator, dou by dou x, dou by dou y, and dou by dou z. In respective columns we have to write. In the third row we have to write the component of vector field vx, vy, and vz. When you simplify this, then we got del cross v. So that is x cap into dou vz by dou y minus dou vy by dou z. Like that I have to multiply or solve the determinant, then we will get the del cross v, the curl of a vector field. To solve this curl of vector field, we should know how to solve the determinant forms. Okay. The curl of a vector function v is like any cross product. We cannot have curl of a scalar functions. This is important. If any scalar function is given, then if they ask find the curl of that scalar function, that is meaningless. We cannot find the curl of any scalar functions. So curl of a scalar function is meaningless. The curl of a vector field is again a vector. Here these unit vectors in the final result will represents it is a vector function. Then what is the significance of finding the curl? The physical significance are mentioned here. The curl means something formed into a curved or spiral shape. The curl of a function del cross v, that is represents, is measure of how much the vector v curls around the point. For example, in the following diagram, the vector function curl around z-axis in xy planes. Here this is xy plane. In xy plane, the vector field arrow mark representing the revolving around z-axis, that we call it as curl around z-axis. Now the direction of this curl is along z-axis, but the vector field is curl in a xy plane. How to find the direction? This is easy. Using thumb rule, we can find the direction of the vector field. The fingers should be curled around the direction of the vector field, and the thumb indicates the direction of the curl. Suppose these arrows are revolving in opposite direction, that means like in this directions. Okay, I'll draw here. This is z-axis. Now these are curl around z axis in this direction. Then we should represent the direction of del cross p in negative z axis. We should curl the fingers of right hand in the direction of the vector field. Then the thumb becomes downward. That downward thumb indicates the divergence. The curl of a function phi is in negative z axis. Okay. Like that we have to represent the direction of the curl. So this is physical significance of curl. The main thing is here, it is measure of how much the vector is curls around the point. Now take a problem on this. Find the curl of a function. Here two functions are given. We have to find the curl of these two functions. For that, first we have to write del cross vector field VA. So what is del? Del is the operator x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. Del cross product, the vector field is minus of y x cap plus x y cap. Now the easy way is to write in determinant form and solve that one. So this can be written in determinant form. The first row is unit vectors x cap, y cap, z cap, and the second row are partial derivatives dou by dou x, dou by dou y, dou by dou z. We have to write in respective columns. And the third row is the vector field. Here first term is unit vector x cap. For that we have to write in first column minus of y, and second one is x y cap. So it is under y cap x, and the z term is 0. Yes, now I have to solve this one. How to solve this one? X cap into these two products in opposite order. So dou y by dou 0 is there. It is dou x by minus of dou 0 minus of dou x by dou z. Next one is middle term minus of y cap into the bracket. We have to multiply these two. So dou x by dou 0 is there. So dou 0 by dou x is 0. Then minus. So minus of dou minus of y by dou z, and the third term z cap. So here dou x and here x. These two terms, dou x by x, dou x by dou x minus of dou by dou y minus of y. So dou x by dou z, this x is independent of z. For that the value of this term is 0. Then 0 minus of dou minus of y by dou z. Here it is a partial differentiator. For that this y is not contains z, that means independent of z. For that this is also 0. The last term is only left, is z cap. Dou x by x is 1 minus dou minus of y by dou y, so it is minus of 1. So finally we get 2 z cap. The curl of vector field P is 2 z cap. This z cap indicates the direction of the curl. Next, second one is PB is equal to x y cap. So again we have to write del cross P. Directly I am writing here in the determinant form. Del cross PB is equal to, so write the arrow mark that represents a vector field, x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. And in third row we have to write the components of vector field. The components of vector field is here: x component is 0, y component is only present, that is x, and z component is 0. We have to solve this one. Simple. First write x cap, the remaining two cross product. Here dou y 0 is 0, dou x by dou z is 0 because this is independent of z. Not independent, it does not have z terms. We have to partially differentiate. If it is complete differentiator, then its terms may be different. Then minus of y cap for this second one. Dou x 0 0, so it is 0 minus 0. The third term is z cap plus z cap. It is x dou by dou y, dou x by x, dou x by dou x, minus of this is 0. For that dou x by x is 1, so it is z cap. The curl of vector field VB is z cap. So like that we have to find the curl and divergence of a vector fields. Okay. So this is enough. Now take the assignment question. The assignment questions: calculate divergence and curl of a following vector functions. Here three vector functions are given. You have to find the curl as well as divergence of this same vector field. Thank you.